Hello guys, good morning, good afternoon, good evening, depending on where you are. My name is CPA Makan. Today I will be taking you through again a unit or a subject called quantitative analysis. And I say that quantitative analysis has been given several names. When you go to CPA, it is called business mathematics and also quantitative analysis. And when you go to colleges and universities, they have changed the name and given to be a management mathematics, and they have actually grouped into levels. So therefore, I'm just handling this particular unit by focusing all the areas, that is CASNEP and colleges and universities. So therefore, I would like you to enjoy this particular lesson as we begin. So today, I will be taking you through linear programming. Linear programming. Now, when you talk about a linear programming, we are referring to a tool that is mainly used to maximize the profits and minimize costs. And in this case, it is telling us that there is a linearity concept. When you talk about linearity, means that when the revenue increases, also the cost increases. Correct? And if you decrease the revenue, also it means that the cost will also what? Decrease. So therefore, in this particular area, we want to see how to maximize profits. So we are going to focus mainly on profit maximization, and cost minimization. So these two concepts are very important when it comes to linear programming. Therefore, in this case, we want now to focus on what are we supposed to do in order to maximize profits. One of the major things that we need to do to maximize profits is to do enough marketing. Correct? Number two is to ensure that we increase the selling price per unit. Number three is to ensure that we lower all the operational costs. When you analyze now these variables, you'll be able to maximize what? Profits. And therefore, for us to maximize profits or minimize losses, we are facing some challenges. So for us to maximize profits, we have also some of the limitations. For instance, you might be in a position to maximize profits, but you don't have enough labor. You might also be in a position to maximize profit, but you don't have enough capital. You might also be in a position to maximize profit, but the time available is limited. So we have what we call limitation that is affecting this linear programming. And therefore, the limitations or those shortages that will interfere us from maximizing profits is what I call constraints. So these are limiting factors. These are limiting factors that will hinder your performance. You are aiming to increase the profits, but unfortunately, because you don't have enough labor, you don't have also enough capital, you don't have also enough time, then it means that these two objective functions will be affected. And therefore, we have to be very careful when we are introducing these particular elements called constraints. These constraints here means that in this case, you can either decide to use the entire available constraints, or you can use less, and maybe it can also mean you cannot go beyond that. For instance, we have only 24 hours in a day. Correct? These 24 hours in a day, you can either utilize the entire 24 hours in a day in production, or you utilize less of this. You cannot go beyond 25 because there is 24, because there is a limit. Therefore, in the linear programming, we need to have a concept of matrices, because without having the concept of matrices on how to form equations, we are going to have some challenges here. And therefore, the concept of matrices is very important, as I highlighted clearly in my previous videos. Therefore, today I'm going to handle on linear programming. Correct? So therefore, in linear programming, I'm going to focus on two methods. Method number one is what we call a graphical method. So I'm going to use to solve questions using my graphical method on linear programming. Number two method is what we call simplex method. So these are the two methods that are required to be known by the students to answer questions very well when it comes to linear programming. And therefore, I want to start directly with the graphical methods. Graphical method. As the word suggests, graphical method means that we are going to draw some graphs. And for us to draw a graph, we need to have 2 points. Correct? Now, for us to come up with the 2 points, we need to ensure that we have coordinates. These coordinates are very important when we draw now what we call what? Graphs. And these graphs are going to show us where the profit is being maximized. In this case, we are going to have two main areas. So I'm going to use the graphical method first. That is use of graphical method. Now, in the graphical method, these are 2 points you need to note. Number one, you have to ensure that you are able to tell the objective function of the equation. You have to ensure that you have the objective function. So this objective function is either to maximize profit, or minimize cost. So when you maximize profit, it is an objective function. And if it is to minimize cost, then it's also an objective function. Now you have to know how to form the first one. The second one is what we call constraint functions. Constraints function. These are equations or inequalities that are limited to the availability. These are functions or equations that are limited to the availability of the limiting factors. It can be hours, it can be labor, it can be machine. So therefore, machines, maybe you have 5 people that you have employed. Unfortunately, you have only 4 computers. So it means there will be 1 person not able to use. So for that matter, we say that is a limiting factor. Now, we want now to proceed from these 2 elements here. And we are going to use the graphical method to solve questions. So therefore, let's go to example 1. Let's go to example 1. I hope you are there. There is example 1 there. I would like to do some few questions right away from example 1 to the last one, but I will be skipping those ones that need us to use simplex method because today's lesson is purely graphical method. So let's see example 1. A company makes 2 products, 1 and 2. Each product requires time on two machines, A and B. The specification for each product are as shown below. So we have this particular element question here. So we have been given this question here. We have product. We have product 1 and product 2. Then we have machine A, machine B, and you have labor, material, and labor cost. material and labor cost per unit. Then we have the selling price. Then we have the maximum possible units. Now, in this case, they are saying process machine A, we have 2 hours here and 2 hours here. Machine B has 1 hour here and 2 hours there. Material and labor, we have 14 here per unit and 15 here per unit. Selling price, we have 16 here per unit and we have the other one 18 per unit. Then the maximum number of units, we have 130 and the other one is 150. That is the information that we have been given. Now, when you look at this information here, we are able to tell exactly the particular type of equation that we have. In this case, you can see we have the machine A and the machine B. And we have product 1 and product 2. It means that for you to produce 1 unit of product 1, you need 2 machine hours. You need 2 machine hours in A and 1 machine hour in B. To produce 1 unit of product 2, you need 2 hours of machine A and 2 hours of machine B. So when you combine them, you will now be able to get what? One production of 1 unit. Now, when you look at it carefully also, we have material and labor cost. And we have also the selling price here. The reason why you have been given the 2, the reason why you have these 2 is to calculate what we call contribution margin. Correct? And this, the last one, this one here, is to tell you that that is the maximum number of units you can produce. Therefore, these 2 here will give you what we call the objective function. Objective what? Function. And objective function here is to maximize contribution margin. So therefore, how do you get contribution margin? It will be the selling price minus actually the cost here. This which is manufacturing cost. In this case, it will be the selling price minus the manufacturing cost. Selling price minus the manufacturing cost. You get now the objective function. So let's see, for example, for product 1, your contribution margin is 16 minus 14. Your answer is 2. That is your contribution margin per unit. Then for product 2, it will be 18 minus 15. Your answer is 3 shillings. So therefore, it tells you that these 3 shillings, these are now your contribution margin. Correct? Now, the question is continuous by saying, the amount of time available on machine A, the amount of time available on machine A, and all these will be 360. Therefore, you say here, availability here, availability, that the total amount of time for machine A is 360. Sorry, 360 here. And for machine B is 260 hours. So therefore, it means that there is a constraint here. The limiting factor is machine hours for that matter. So therefore, these 2 here, that is machine A and machine B, will form what they call the constraints function. Then the cost and the selling price will give you the objective function. Question is saying, the question is saying, formulate the above as a linear problem and determine the number of units produced in product 1 and product 2, which should be sold in order to maximize total contribution for the month. So we have been told to first of all determine the functions. That is now the equations. Then from there we determine. So let's see how to go about. So number one is formulate linear programming problem. Linear programming problem. So the linear programming problem, we go back to our objective function and constraint. So in this case, we don't know how many units of product 1 were produced, but we have been told there is a maximum of 130, which means it cannot go beyond 130. Then we have also the maximum units for, we don't know the maximum units for 2, but we have been told it cannot go beyond 130. Therefore, our work will be very simple. We say now let x and y be total. The total units of 1 and 2. Once you have this one, then you now say, okay, from the objective function here, objective function, which is contribution margin, you can let that contribution margin be what? Be z, equals to, we have said, contribution per unit from product 1 will be 2 shillings. But how many units for product 1? X. We have also calculated the contribution margin for product B, and we have found to be what? 3. And we have said the total units is what? 3. The Y, sorry. Therefore, for us to calculate the total objective function, it will be x times 3. You get 2x plus 3y. That is your first equation. Second equation is now these constraints you are seeing here. That the machine A and machine B will have 360 minutes and 260 minutes also for B. Therefore, there's a limiting factor. We come and say now constraints. The first one is 2 times x. You get 2x plus 2 times y. You get 2y. Should be equals to or less than 360. The second one is 1 times x. You get x plus 2 times y. You get 2y equals to or less than 260. Now, these are the constraint factors, but we have what we call non-positivity element. This non-positivity element means that in the production, we cannot produce negative, but you can only produce units or no production. In this case, you can say x and y is greater than or equals to 0, meaning that you can either produce none or you can produce greater than 0. So therefore, these are the equations that you are asked to derive. So if I'm an examiner, I will ensure that I give, this is 1 mark, 1 mark, 1 mark, and 1. These are 4 marks. But by reading and interpreting the question like this and also calculating this contribution margin together with the saying, let x and y, it will also form another mark. If I'm the one marking, I will give 5 marks on this. Correct? That is how you are supposed to have a formulation. Once you have done formulation, what do you do now, class? Your work is very simple. Now we need to use the graphical method. Graphical method, your work is very simple. You are supposed to form equations. And for you to form equations, you are supposed to convert the inequality equations here into normal equations. So convert these inequalities into equations. How do you go about? Now we remove this less than or equals to and introduce equal sign. So therefore, in this case, for using graphical method, so we now convert this. So we say now it will be 2x plus 2y should be equals to 360. The other one is also x plus 2y should be equals to 260. So once you have converted them into equations like this, then your work will be very simple. Also, this one you say x should be equals to 0 and above, then y should also be equals to 0. But for the objective function, it is already having equal sign. Because it has an equal sign, you don't need to do anything. So we have to use only this to draw the graphs. This equation is here. On this one now, we need to draw the coordinates. For instance, my graph will be like this. Remember class, we are going to bring up a model, a graphical model, not the actual one, but the graphical model from the information we have here. So for instance, I will now take the first equation, that is 2x plus 2y equals to 360. Once I've now done that, I would say I want to find out the coordinates now. I say x and y like that. Then I say if x is 0, what will be the value of y? So if x is 0 here, which means 0 times x is 0, y will be 360 divided by 2. Your answer is 180. Correct? Then you come again and say if y is 0, what is the value of x? If y is 0, what is the value of x? 180. You can see that. Then read the coordinates here. It will be the form of x, y. X, y. I've seen some students saying, to write the coordinates, they'll say 0, 180. Then 180, 0. No, it is wrong. It should be x, y. X, y. So the first one is 0, 180. Then the other one is 180, 0. So these are the coordinates. Now, once you get these coordinates, I'm saying don't read like that. You read downwards. These coordinates means that x is 0, y is 180. So when x is 0, y is 180, assuming it is somewhere here. This is 180, like that. Then the other one is 180, assuming it is here, 180. The other one is x. Then you use your ruler, join these two. Now, this equation here is 2x plus 2y equals to or less than what? 360. That is your first equation, and you have already presented on your graph. The second now is this second equation here, which is now x plus 2y equals to 260. Again, you proceed, say x, y. Then you say, if x is 0, y is 130. 130, which means 260 divided by 2. Then if y is 0, x will be 260. So what will be your coordinates, class? What will be your coordinates, class? We read x, y, x, y. So it will be 0, 130, then 260, 0. I'm still saying don't read like this. You read downwards. Then plot these coordinates now in your graph again by saying it is 0 against 130. Assuming here is now 130. Then we have 260. Okay. Just a minute. Let me minimize this. Remember, this is a model. So let me just model it this way. This is 180. This graph here is 180. Here, this point here is 180. Now, this graph here, it has already 2x plus 2y equals or less than 360. Now, I want to locate, the second one is 0, 130, 0, 130, then 260, that is on X. So here is 260. Here is 260 against 0. Against 0. Against 0. So 260 against 0. So join these 2 points. Can you see what is happening? Now, this graph here, this one is now x plus 2y is greater than or equals to 260. Now, when you look at it carefully, it says 2x plus 2y is less than or equals to 260. So where is that region? It means the region is below. It is below this line here. So therefore, it means this area here is unwanted. Because it is unwanted, you shade like that. Correct? Then, this line here also says it is 2x plus 2y is less than or equals to 360. Where is that region? It means that the region is below. It is not the other side. So we shade again this particular point like that. Then, we have also x is equals to 0, which means x is equals to 0, the whole of this. So it means there is nothing you are shading, you are including them, and like that. Oh, then it means our region is here. That is now the area. This area here is where we shall be maximizing our profits, which we say z is equals to x plus 3y. 2x plus 3y. So your work is here. Once you have located your region, look at the corner points where the region is. We can describe this region by saying this is A, this is B, this is C, and this is D. Once you have written like that, locate the coordinates now. Let's get the coordinates. Let's say now A equals to, what are the coordinates for A? You say x 0, y is 130. B. Now when you look at B, B is where the two equations are intersecting each other. Therefore, it means these two equations here, this point here, you have to solve it simultaneously. Solve these equations simultaneously for you to locate the coordinates of B. Correct? So let's solve these two simultaneous equations to find out the coordinates of B. So in this case, it will be 2x plus 2y equals to 360. Then x plus 2y equals to 260. So we can use the elimination method there. So this one can be subtracted, gives you 0. Therefore, this one will give you yes, this minus this is x plus 0 should give you this minus that, you get how much? 100. It means x is equals to 100. What about y? So this value of x substituted either. So let me substitute in the second equation so that where there is x I put 100. So it will be 100 plus 2y equals to 260. This one crosses the other side. It becomes 260 minus 100. Your answer is 2y equals to 160. Then y alone equals to 80. Oh, it means that point B here, x is 100, y is 80. Correct? Then C, we had already C, which says C is equals to 0 and 180. No, so not 0, but 80. 180. X is 180. Y is 0. Then D is 0, 0. Here, 0, 0. Now, once you have this information, your work is very simple now. We want to find out at what point are we maximizing the profits? At what point are we maximizing the profits? at what point? Is it at point A? Is it at point B? Is it at point C or at point D? So from this equation, your work is very simple. You just say my equation was Z equals to 2x plus 3y. That was the equation you are given. Correct? Now from here, we now say, if I substitute point A, point B, point C, and point D, what will be the answer? I come and put the equation here, 2 into point A, it says that 2 times x. X is 0. X is 0. Then you say plus 3 into y. In this case, it is 130. Then you get your answer. B will be 2 into x. In this case, for B is 100. You put here your 100. You say plus 3 into y is 80. Y is 80 here. Then C, we have already 180 here. So it will be 2 into 180 plus y is 3 here, which is 3 here. Then y is 0. You put there your 0. Then the last one is x. X is 0, y is 0. So it will be 2 into 0 plus 3 into 0. So now in this case, you substitute this one. We substitute now in these equations. Now you take your calculator. So this times this is 0. So this times this get 390. Then this times this is 200 plus 240. That is 240. You get now 440. Then this times this get 360. 360. Then this one will give you 0. So at what point do we have the highest profit? So it tells us that the highest profit will be at point B. So therefore, your decision now will be profit. Now the point is now profit is maximized. Correct? When is maximized when 100 units of X and 80 units of Y are produced. That is how to answer this particular question. So what is very important is how to come up with a model which is representing the information that you have been given. So therefore, this model is very important. So you can see our region is here, but we can only maximize profits at that point when Y is 80 and X is 100. That is how you are supposed to work out that question. Example 2. Example 2. Now, example 2 there says, ABC Limited, ABC Company produces 2 products. Unit profit for product A is 60 shillings and for product B is 50. Each product must pass through 2 points or 2 machines, P and Q. Product A requires 10 minutes on machine B, P, and 8 units on machine Q. Product B requires 20 minutes on machine P and 5 minutes on machine Q. Machine P is available 200 minutes a day, while machine Q is available 80 minutes a day. The company must produce at least 2 units of product A and 5 units of product B each day. Units that are not completed in a given day are finished the following day required, Roman 1, formulate the above as a linear programming problem. 2. Solve using the graphical method and determine the most profit daily production plan. So, Roman 1 is about formulation of inequalities. Then Roman 2 is purely about solving the values and indicating exactly at what point or how many units shall we produce in order to maximize profits. So let's see. And before we do, we extract information first. Information we need to extract is the table. Let's see the table. They are saying ABC company produces 2 products. So you can say we have product A, we have product A and product B. That is what they are saying. 2 products. Unit profit for product A is 60, which means profit per unit for product A is 60 shillings and profit for product B is 50 shillings. That is objective function. Each product must pass through 2 machines. Each product, for you to produce 1 unit of product A, it must pass through machines. So we have machine P and machine Q. Machine P and machine Q. You can see, for you to produce only 1 unit of A, it must go through these machines. Then for you to produce 1 unit of B, it must go through these machines. So let's see. Okay. Each product A requires 10 minutes on machine P. A requires 10 minutes on machine B and 8 minutes on machine Q. You can see that. Then the other one says product B requires 20 minutes on machine B, 20 minutes on machine P, and 5 minutes on machine Q. 5 minutes on machine Q, like that. Machine P is available 200 hours. This one here, P, available 200 hours, which means like this, 200 hours. 200 minutes, sorry. Then machine Q, available 80 minutes, 80 minutes. Then this one is now we say availability. Correct? Then we go back to the equation now. There was a profit. From the opening paragraph there, it was saying there is 60 units, 60 shillings per unit for A and 50 for B. So this table is enough for us to formulate A. A, or Roman 1, they need you to come up with the linear programming problem. So you can either begin from profit function or a constraint function, no problem. You can just begin from any. So let me begin from objective function. Now this one now we say the profit now, profit is given, that is a symbol for profit, right? Or you can put Z or whichever the letter you want. Should be equals to 60 times how many units for A? You don't know. Put it X plus 50 units, 50 shillings. How many units for Y? Put Z. So that is already the first equation. Second equation is now from the constraints here, which means it will be constraints, this objective function, then constraints, now for that matter, it will be 10x plus 20y should be equals or less than what? 200. The second one will be 8x plus 5y equals or less than 80. Then the other constraints that there will be no negative. So there will be non-negativity, which is x and y should be equal, greater than or equals to 0. So these are the equations they want you to introduce. Then Roman 3, the Roman 2 now is to solve. Find the point of maximization using graphical method. Graphical method. So we are using graphical method. In this case now, we said convert the inequalities into equations. So you convert this inequality. This one is the one we shall be substituting for us to find out at what point are we maximizing the profits. But These inequalities here are the ones we convert into equations. So the first one will be 10x plus 20y should be equals to 200. Then 8x plus 5y should be equals to 80. Then x equals to 0 and y equals to 0. Then once you do this one, the first two here, you get the coordinates for that matter. So you say now 10x plus 20y equals to 200. Then x and y. So if x is 0, y is 200 divided by 20. You get what? If x is 0, y is 10. If y is 0, x is 200 divided by 10. You get what? 20. Coordinates here, these are the coordinates. This and this. So it will be 0, 10, 20, 0. Second equation, which is now 8x plus 5y equals to 80. Then x, y, like that. So when x is 0, y will be, this divided by that is 16, right? 16. When y is 0, which means y times 5 is 0, x will be 10. Coordinates will be x, 0, 16, then 10, 0. Once you have this information, we plot now in our graph. Let's now have our model. Our model now will be like that. Remember, this is not the accurate, but this is a model. So when you are in exam, don't ask for the graphical paper, but this one you just need to give a model. In this case, this is our model, like that. And we mark this model here. So we now put in this information, 0, 10. So here is 0, then here is 10. Then 20, 0. So I can say here is 20, here is 20, and here is 0. So I join these points like that. You can see that. Then I go to the second, 0, 16, 0, 16. Maybe 16 is somewhere here. 16 is somewhere there. And here was 20. Then 10. 10 is here, somewhere here, 0. So here is 10. So join 10, x is 10, 0. This one is 0, 10. 0, 10. Oh, sorry. This is 16, okay? So this is 16, 0, 16. So 16 is somewhere here. Sorry. That is your 16. So we join now this point and this point like that. So it tells you now that this equation, we don't need this side, so it's shaped like that. And ensure that these lines, these graphs here are properly labeled. So this one is the second one, which is 8x plus 5y. Don't say equals to, because you are showing them in a graph, it should be the inequality that you have there, which is equals to or less than 80. This one is 10 plus 10x plus 20y equals or less than what? Or less than 200. So then this is y. Y is like that. Then this is x. Then you don't need this side. So it means that your region is there. So now read the coordinates for where the lines are cutting each other or intersecting. So you can say this is point A, this is point B, this is point C, and this is point D. Read the coordinates there. A, what is A? A is 0, 10. B, now when you look at B, these two graphs are intersecting at this point. Therefore, it means you have to solve this equation simultaneously. So when you solve this equation simultaneously, it will be now 10x plus 20y should be equals to 200. Then this equation here is 8x plus 5y equals to 80. Now you choose whichever the method, either substitution method, elimination method, or matrix method. So use any method to solve this equation. Now when you look at this question carefully, the simplest one is to use the elimination method. So let's eliminate 1. So what I can do is to ensure that I choose either to eliminate x or y. But let me now eliminate y here. So I'll ensure that we have 20 here and I have 5 here. So I have to ensure that 20 is here, 20 is also here. So what then it means that this second equation here should be multiplied by 4 so that I get 20 here. So therefore here will be 4. So when you put now 4 on the last equation here, it will tell you that this 4 here, this 5 here will be 20. Now for the upper one, already we have 20 there. So it means that first line you multiply by 1 because you want to maintain your 20. Now can you open the graph now? When you open now, say 1 times 10, 1 times 20, and 1 times 200. 4 times 8, 4 times 5, and 4 times 80. So therefore let's open that equation. So it will be 10x plus 20y should give you 200. This 4 times 8 is 32x plus 4 times 25 is 20y should be equal to this times it to get what? 320. Now let's eliminate now. We subtract. So it will be now 10 minus 32 is negative 22x. Then this one is automatically 0, should be equals to negative 120. Then now you divide by negative 22. Divide also here by negative 22. So x alone will give you something to do with 5.5. Once you get your 5.5 in this case, you come and substitute either the first equation or the second equation. Now let's substitute the second equation for instance. So if I substitute this second equation by saying 8 times x, which is 5.5, plus 5 plus 5y is equals to 82. When you solve it that case now, you say y, you'll find that y equals to 7.3. Now, these points here, 5.5 and 7.3, are the coordinates for point B. So therefore, in this case, you say now B will be 5.5 and y is 7.3. Then C is 10, y is 0, D is 0, 0. Then once you are through, you come and work out the way we have done the first example by saying from the equation Z or any letter you have put there is, equation was 60 plus 50 y. Then say A, B, C, and D. For A, you substitute your equation 60 into A, 0 plus 50 times into brackets 10. You get the answer. B is 60 into, you read as it is, 5.5 plus 7 plus 50 times 7.3. You get the answer. C is 60 into 10 plus 50 into 0. Then D is 60 into 0 plus 50 into 0. Then you get your answer. Where you will find now the highest amount value here, it means that is the point where you are maximizing your profits and you make your decision. That is how this linear programming using graphical method is. So therefore, my next lesson is to solve the same linear programming equation by using what they call simplex method. Correct? So therefore, I hope and believe that by the end of the lesson, any question you'll be in a position to solve a question relating to linear programming by use of graphical method. And therefore, I welcome you. If you have not subscribed to my YouTube, kindly go to CPA Makan, subscribe, like, and share with your friends, and ensure that your notification bell is always on to ensure that you get this notification on time. And if you have any question, because I'm going to attach these questions on that particular video. On that particular video, the questions will be there. It is your responsibility now to work out all the questions from question 1 to question 8. And then if you have a challenge, you can reach out to us and I'll be able to guide you on each and every question. So therefore, I welcome you to the next lesson, that is simplex method. Thank you and have a wonderful time.